we're looking at notes 9 for rational exponents. So what does rational mean? Rational means ratio, which really means fraction. So given a to the mn power, that is the same thing as the nth root of a to the m power. So notice the numerator goes inside the radical, it becomes the power for a. The denominator goes outside the radical, it is the index. Okay, so looking at a couple of examples here to apply this knowledge. So if I have 7 to the 1/2 power, that is the same thing of saying the square root of 7 to the 1st power. And 7 to the 1st power is just 7, so it's really just like saying square root of 7. Okay, since 7's prime and you can't simplify, that's your final answer for that one. Okay, let's look at another one, 125 to the 1/3 power. So that's the same thing as saying the cube root of 125 to the 1st power. Remember, numerator here, denominator here. So 125 to the 1st power is just 125. And so basically we're taking the cube root of 125. With 125, however, I can break that up to 25 and 5, and then 25 to 5 and 5, drag down this 5. And since it's cube root, I'm looking for sets of 3. I do have a set of 3 5s, so 5 comes out. 5 is my final answer with nothing left inside the radical. Okay, so 50 to the 1/2 power would be the square root of 50 to the 1st, which is really the square root of 50. All right, and 50 is 25 and 2. And then 5 and 5, drag down the 2. Square root means I'm looking for sets of 2, so I do have a set of 2 5s. So 5 comes out, 2 stays in. That's my final answer for that one. I think you're catching the drift, but we'll do one more. So 12 to the 2/3 power means the cube root of 12 squared. But then 12 squared needs to be simplified, so it really means the cube root of 144, because 12 squared is 144. And then when you start breaking up, you kind of go back to where you started. 144 is 12 times 12, which would be, you can either do 3 and 4, 6 and 2. So I'll do 3 and 4. Drag the 3 down, the 4 is 2 and 2. The 3 comes down, the 4 becomes 2 and 2. So here, since I'm talking cube root, I have a set of 2's, and looks like that's it. So I have a set of 2's, cube root of 3 times 3, which is 9, times 2, which would be 18, stays inside. So that's some simplifying for you, pressing on a little bit more. So if I have something like 3 to the 1/2 power times 3 to the 1/2 power, that works the same as if it were x's. So x to the 3rd power times x to the 5th power is x to the 8th power, because if you have the same base, meaning like x or y, if they're both x or they're both y, then you keep the base the same, like we did here, we kept the base the same, and you add the exponents. So same here, my base is the same, my base is 3. Okay, so I keep the base, add the exponents. Well, 1/2 plus 1/2 is 1. So it's 3 to the 1st power, which is really just 3. Okay, so looking at another example, 4 to the 1/4 power times 4 to the 1/4 power times 4 to the 1/4 power. So we have the same base of 4 throughout, so I keep the base of 4 and add the exponents. 1/4 plus 1/4 plus 1/4 is 3/4. Okay, because you add the numerator and you keep the denominator the same. So 4 to the 3/4 power. And then we go back to what we learned up here and we convert that to a radical. So this is like saying the 4th root of 4 to the 3rd power, because that's the index, the numerator is the exponent. So 4th root of 4 to the 3rd power, well, 4 to the 3rd power is 64. And then you start breaking up 64, 8 and 8, 4 and 2, 4 and 2, and then 2 and 2, drag down that 2, 2 and 2, drag down that 2. Since it's 4th root, I need sets of 4, so my answer is 2, 4th root of 2 times 2, which is 4. So then I'm finished there. Okay, so looking at a different type of example, 10 to the 1/3 times 100 to the 1/3. Notice the bases are not the same. So if you have different bases, convert each to a radical first. Okay, so this is like saying cube root of 10 to the first. Okay, and this is like saying cube root of 100 to the first, which both of these are just 10 and 100. So that can be done now. That's legal. I have an index of 3 times an index of 3. All right, so I multiply the outsides and outsides and insides and insides. So this would be cube root of 1,000. Okay, once I multiply. So then I start basically the same thing as I've been doing, breaking up. So obviously 10 and 100, and then 10 is 5 and 2, and then 100 is 10 times 10, and the 5 and the 2 drag down for the ride, and the 10 is 5 and 2, and this 10 is 5 and 2. Since it's cube root, I'm looking for sets of 3, so I actually have 3 5s, and I have 3 2s. So it's 5 times 2, which is 10. The cube root of 1,000 is 10. Okay, so now again, same situation. My bases are not the same, so it doesn't work the same as before. Instead, if I have different bases, I should convert these to radicals. So this means square root of 2 to the first, which again isn't necessary. This means square root of 18 to the first, which the first isn't really necessary. Okay, and so here, because my indices are the same, I am allowed to multiply. It's legal. Okay, so 2 times 18 is 36, so this really means the square root of 36. I could write the index of 2, but I don't have to. All right, and so then the square root of 36, y'all know, it's just 6. Okay, so now we're going to talk about converting to radical form. So assume all variables are positive, that way we don't have to deal with absolute value. So before we looked at numbers, now we're looking at variables. So to convert this to radical form, remember the denominator is the index, the numerator is the power. So that is the same thing as 5th root of x to the 3rd. There's nothing that can be simplified there, so I'm done. However, in this situation, I have square root of x to the 3rd. So if the numerator is smaller than the denominator, nothing can be simplified here. But in this case, the numerator is larger than the denominator. That means I have 3 x's and my index is 2. So I can circle a set. The x comes out, square root of x stays in. The 2 for the index isn't necessary. And the absolute value bars aren't necessary because I said assume all variables are positive. Okay, here we have a fun situation because I have a negative exponent. Hopefully you remember your rules of powers of exponents. If you have something like, off to the side here, let me use a different color, x to the negative a, that's the same thing as 1 over x to the positive a. That is a rule of exponents that you learned in Algebra 1. So if you have a negative exponent, if you flip the variable or number that the exponent belongs to over the fraction bar, then the exponent becomes positive. So in this case, we're going to do the same. We're going to call this 1 over x to the positive 1/5, because we always want positive exponents. And then we're going to convert to a radical, so 1 over 5th root of x to the 1st. Okay, and that would be finished, except y'all know you cannot have radicals in the denominator. So this means I need to rationalize. So I need to multiply by 5th root of x to the 4th on top and bottom, because I need 5 x's in order for the denominator to be rationalized. So here across the top I've had 5th root x to the 4th over 5th root. This becomes x to the 5th. So what happens here is the x comes out, and then on top I cannot simplify that. So that's my final answer for that one. Okay. Here I have x to the 0.75. Well, hopefully you know that 0.75 can be converted to 3/4. So then that could be 4th root x to the 3rd, which can't be simplified. because I don't have enough x's to come out here, okay? X to the 1.4. So I need to convert that 1.4 to a fraction. So off to the side, this one was easier, it's more commonly known. Off to the side here, 1.4, probably not as commonly known. You can convert it. That is the same as 14/10. Okay, and then that simplifies to 7/5. So x to the 1.4 is like x to the 7/5. So it's like 5th root x to the 7th, which means I have 1, 2, 3, 4, 5, 6, 7 x's. So a set of x's comes out, 5th root of x squared stays in. Okay, last concept. Convert to exponential form. Assume all variables positive again. So recall another property from Algebra 1. If you have a to the m power raised to the n power, a power to a power, you multiply the exponents. Okay, so converting this radical to an exponent, I need to remember that there's an implied 2 here and an implied 1 here. Okay, so this is going to be 5 to the 1/2 power. Now it's an exponent. Okay, similar here, I have to remember there's a 1 here, so this would be 2 to the 1/3 power. Remember, index in the denominator, power in the numerator. Okay, this would be converted to x to the 3/4 power. I'd be done. All right, here on this one, number 4, you are looking at square root of x to the 1st, y to the 1st. So since they're both in the square root, it's like x to the 1st, y to the 1st is being raised to the 1/2 power. So that distributes into both exponents here. So it's like x to the 1/2, y to the 1/2. Now those are in exponential form. Okay, so here on this one, similar concept. Both of these, the 2 is to the 1st power, the x is to the 1st power. So this is like 2 to the 1st, x to the 1st is all raised to the 1/3 power. That's what cube root means. Okay, so that 1/3 distributes to both. So that'd be like 2 to the 1/3 power, x to the 1/3 power. And that's it on those. Okay, this is very similar too, except this 5 has a 1st power, but this x has a 3rd power. So we have 5 to the 1st, x to the 3rd, raised to the 1/2 power because they're both in the square root. So that gets distributed in. So we would have 5 to the 1/2 power, but x would be to the 3/2 power because 3 times 1/2 would be 3/2. Okay, here moving along, we have inside, we're following PEMDAS big time. In here, inside here, we need to convert this. I'm going to use brackets for the 3rd power. In here we have x to the 1/4 power, right? Because there's a 1 here and a 4 here. So that'd be like x to the 1/4 power. Raised to the 3rd power, so remember power to power, multiply. So that would be x to the 3/4 power. Okay, and then similar situation here. I'm going to kind of put brackets around 4x and then to the 6th, okay? And then I'm going to convert this to an exponent here. So this is 1/3 because it's cube root. So that 1/3 will actually go to both. But if you wanted to first, you could multiply these together. So here, I would prefer to do that. Raise this power to this power first. So 6 times 1/3 would be 2. So both of these would get a power of 2. So 4 squared, x squared. And so that would simplify, because it's a number, to 16x squared. And that would be your final answer. Okay, so moving along here, we have square root. So remember, that's like 1/2 power. So we've got 2x to the 5th, all raised to the 1/2 power. So again, my preference is to multiply these together first. So you have 2x raised to the 5/2 power, and then go ahead and distribute. So you'd have 2 to the 5 halves, x to the 5 halves. Okay, and on this one, you really can't simplify because 2 to the 5 halves would go back to a radical and not a whole number like this one. So this one you're finished, unlike that one. Okay, so on this one here, you have 8x squared all raised to the 1/5 power because the index there. So distribute these together first. You would get 8x to the 2/5 power, and that would distribute in. So you would get 8 to the 2/5, x to the 2/5. Okay, and then again, because that's a fraction, you don't want to simplify that, just leave it. Last one here, what we're going to do first is we're going to simplify what's underneath here. So we're going to have 8 over, this is going to become x to the 2/3 power. And then last but not least, we like to have everything on one level, not something down on the bottom of the fraction. So when we move this x to the top with the 8, remember flipping over the fraction sign will make this a negative 2/3. And now I am done.